Let's now take a look at the different use cases for EBS volumes. As we have seen, we have several types of EBS volumes. We will start with the GP2, which is recommended for any type of workload. It can be used as a boot disk for MBR installation or a boot tape. It can be used in an office environment to make virtual desktops. It can also be used for interactive applications that require low latency, such as web applications with user interaction. It can also be useful in test and development environments because there are many possibilities with this type of hard disk. The size of these hard drives can vary from 1 GB to 16 TB. GP2 volumes support burst mode and can extend their input and output IOPS capabilities to 3000 operations per second. The maximum volume of IOPS is 16,000 operations per second. This means that if we have 3 input and output operations granted per gigabyte of our volume, we reach the maximum number of input and output per second when our volume has a size of 5,334 gigabytes. Let's see how to create an EBS volume in GP2 in the console. For this, I go back to my EC2. I will go into the volumes and I will arbitrarily create a new volume. Here I can define the type of volume. We want a GP2 in SSD. We will be able to define the size in gigas of our volume with a minimum size of 1 giga and a maximum size of 16,384 gigas. Here we see that for 100 gigas we have 300 input and output operations per second out of the 3000 that we can have at most. What is interesting to see here is that if we change the size of our hard disk, we put for example 1500 gigas, we will have 4500 input and output operations per second. There is therefore an interaction between the size of our hard disk and the number of operations that we can benefit from in relation to the size of the same hard disk, knowing that if we go below 1 giga we will have 100 input and output operations per second, and if we exceed 5,344 gigas, as we saw in the previous reading, we will be at 16,000 input and output operations per second. Here we have the availability zone, so we can see that we are well fixed to our given availability zone. The flow rate does not apply to the GP2 disk. We can eventually choose a snapshot to create our volume from an already existing image. We can also quantify our volume at this level. Let's move on to the next type of volume. We will switch to the IO1 volume type, which is recommended for commercial applications requiring very sustained input and output performance that exceeds the GP2 disk limit of 16,000 inputs and outputs per second per volume. When the limits of GP2 are exceeded, it's necessary to switch to IO1. Supports large database workloads such as MongoDB, Cassandra, Microsoft SQL, MySQL, PostgreSQL, or even Oracle. The size of these volumes can vary from 4 gigas to 16 teras. and we can supply inputs and outputs independently of the size of the hard disk, so we can have a variable size hard disk with variable IOPS. For IOPS, we are at a minimum of 100 for a maximum of 64,000 inputs and outputs per second for nitro type instances, but they are not part of this training. Generally, we will have machines that can run at 32,000 operations per second, but we will first see how this is set in the console for an IO1 disk. Back in the console, we can choose an IOPS disk provisioned on SSD. We will be able to define the size of our hard disk. Let's say, for example, 1000 gigas of hard disk for the minimum IOPS. What will be interesting to note here is that if we change the size of our hard disk, automatically our input and output volume is modified accordingly. There are some limitations. We are still at a 50:1 ratio, so for a giga you have 50 operations per second, and so that was what was interesting to see with this type of volume, while knowing that the rest of the options remain the same. Let's now look at our third type of EBS volume, which corresponds to an HDD type hard drive, so it's not SSD but rather recommended for streaming applications requiring a fast and constant throughput for a rather low price. It's ideal for big data warehouses and log analysis such as Apache Kafka, or applications that use a lot such as Elasticsearch or these kinds of things. It cannot be used as a boot disk. It ranges in size from 500 gigas to 16 teras with input and output operations scalable to the maximum of 500 operations per second. These hard disks have a reading and writing speed of 500 megabytes per second, which can be extended with the burst principle that we have already seen in the different modules we have studied. Let's now see the SC1 model. Corresponds to a cold installed hard disk. It is therefore necessary to stop the machine to reattach the EBS volume. What will be interesting is that compared to the size of our hard disk, if we are at 1000 gigas for example, we see that here our throughput, our number of megabytes per second in terms of writing and reading, is 12 out of 79. The more we increase the size of our hard disk, if we go for example to 16 tera, here we see that we will increase. The most important thing to remember about the STI instance is that the larger the hard disk, the more reading and writing capacity you will have. So we are going to put the maximum to make it more meaningful, so 16,384. 192. It's funny, we don't reach the limit, but it's a type of volume that also has extension capacities, the burst as we have seen, and it's therefore completely modifiable and evolutive. Now let's look at our last type of EBS volume, the SC1, recommended for applications requiring good throughput on large volumes of data but with little file access, so it's a service account that will access all the files and not a very large traffic. This may be important in projects where the cost of storage should be the lowest. Indeed, like the other type of HDD disk, the ST1, this disk cannot be used as a boot disk. Its size can vary from 500 GB to 16 TB. Its volume on input and output operations per second is capped at 250. It can be extended with the concept of burst, thus extended the capabilities for our instance. You can see in the console how it works. In the same way, ST1 will be selected here. As you can see, with a minimum size of 16,384, I reach the maximum in terms of throughput. If I scale down here, I can see that I'm down to 40 megabytes per second with an expression capacity of up to 245. It can be fun to play with, but for the moment it's not very interesting. We will do a quick summary of everything we have seen in this section. The important thing to remember about our EBS volume is that we have GP2 volumes which are for general use and are very low cost. There is a ratio for 3 input and output operations per second per gigabyte with a minimum of 100 input and output operations per second. This can be extended to 3000 operations per second with a minimum of 16,000 in extended capacities. The size of this type of disk can vary from 1 GB to 16 TB, and for each terabyte added, there can be 3000 input and output operations per second. Then we have the IO1 disk type with an IOPS supply independent of the disk size. This is more expensive, but you can define the number of inputs and outputs you need independently of the disk size. With a maximum of 64,000 IOPS for the Nitro type instances that we will not see in this training, or 32,000 for all other instances including Linux AME or T3 micro or T2 micro that we have been using since the beginning of this training. The size of this disk can vary from 4 GB to 16 TB, and the size of the volume, as I explained to you, is independent of the number of IOPS. We have also seen ST1 type disk, which are hard disk optimized for throughput per second. So this disk can range in size from 500 GB to 16 TB and offer a read speed of 500 MB per second. SC1 hard disks are similar in nature to ST1 disks, except that these disks will have less solicitation from users and are therefore useful for applications such as big data, data analysis, and so on. With a single service account, for example, we will be able to support everything with a throughput of 250 MB per second and with disk of 250 GB at 16 TB. So much for our little summary of EBS volumes.